Hey, geometries. This is Geometry Chapter 8 Practice Test, and I'm Mr. Bloom. So let's look at this. Find the value of x. Express your answer in simplest radical form. This is a big deal, simplest radical form. It means I'm not going to multiply it with a calculator to find a final answer with decimals. So here, my first question is 12 squared plus 16 squared is equal to c squared. Remember, I'm using a squared plus b squared equals c squared. This is the Pythagorean theorem. It helps me find the third side when I have a right triangle and two other sides. Okay, so now I got 144 plus 256 is equal to c squared. I add those together, and I get 400. 400 is equal to c squared, and c, if I take the square root of both sides, gives me 20. So that was kind of nice. I don't have a radical there, but I know that that's my answer right there. In this next one, I've got x squared plus 13 squared is equal to 14 squared. And x squared is equal to 169, and this is equal to 14 squared, is equal to 196. Okay, and if you ever you're not really good with stuff, you just kind of go into your calculator. You get 14 squared, it's 196, and minus 13 squared. Okay, all right, and that's gonna be 27. So right now I've got x squared is equal to 27. Now, if I'm going to find this simplest radical form, I got to find the largest perfect square factor in 27. Well, 3 times 3 times 3 make 27, so 9 times 3. Perfect square factor is 9. If I take this like this, I know this is the square root of 9 times the square root of 3. I always put the perfect square first, and that's my answer. So x is equal to 3, the square root of 3. Now, I'm going to be using the space later, so we're going to group this up. Oh, let's undo that. We're going to group, and we're going to shrink it down. That way we still have our solution there. Okay, this last one here, I've got x squared plus 11 squared is equal to 61 squared. Again, remember, Pythagorean theorem. C is the largest side, the hypotenuse. And the legs are A and B. Now, I've got x squared plus 121 is equal to, well, 61. 61 I rarely use. 61 squared. That's 371. Well, I take away 121, and I get 3600. Well, so let's make sure I get these numbers in. Remember, I did stuff on a calculator, but I'm showing on paper what's going on. So 3721, I subtracted 121, x squared is 3600, and now I take the square root, x is 60. So now I know x is 60, that's my answer. Okay, I'm clearly showing the grader what's going on with my answer, how I got it, and supportive evidence that I know how to do it versus just an answer. Okay, those are the things I'm looking for when I grade. Now, in this next one, given the lengths of the sides of a triangle, identify the triangle as acute, right, or obtuse. Remember, the things I'm using here, a squared plus b squared greater than c squared, acute. A squared plus b squared equals c squared, right. A squared plus b squared less than c squared is obtuse. But if it comes out as obtuse, does a plus b, is that greater than c? Notice, this makes triangle. Makes a triangle. Okay, so I've got to check though. Those are the rules I'm running through. So if you don't have them in your note card, make sure you get them. I'm going to group those. Okay, pull that over. Okay, so those are the rules I'm following here. Now, when I set this up, the biggest ones always see 41, 40, and 9. Okay, maybe I should bring it across like this. and go, all right, this is 41. It's way out here. And I'm putting in a less than, greater than, or equal sign in there. Which one is it? So first of all, 9 plus 40 is greater than 41, so it's going to make a triangle. So I've got 81 plus 1600, that's 40 squared. Okay, that's 1681. 41 squared is also 1681. So this is 1681 and 1681. These are equal, okay? So this happens to be a right triangle. Okay, my next one, 10 squared plus 16 squared. What's going to go in there? 20 squared. This is 100 plus 256. Okay, and this is 400. And now I'm looking at this, and that's 356, so that's less than. So this is going to come out as obtuse, and because of that, 10 plus 16 are bigger than 20, so that's 36 is bigger than 20, so this is an obtuse triangle. Okay, my last one here, and that got a little big, so we're going to bring that down. Okay, my last one here, I got 12 squared plus 15 squared, and I'm going, hey, 18 squared, how's that going to be? Well, 12 squared is 144, 15 squared is 225, 18 squared is 324, and we're going to go 18 squared. That's 324, yep, I just had doubts. So I got 324, okay? Now, I add those together, and this is going to be bigger than 324, okay? And 12 plus 15 is bigger than, added together is bigger than 18, but this is an acute triangle. Okay, and that's how I do that section. Now, for each pair of numbers, find a third whole number such that the three numbers form a Pythagorean theorem. Well, I've got 33 squared plus 55 squared, and I'm going to see if that helps me. So I've got 33 squared, okay, and then I got plus 55 squared, and that's 414. I wonder if that's a perfect square. It's not. Well, there's another way I can orient this, okay? This becomes 414, not a perfect square. But what if I do it this way? What if I decide that 55 is my perfect square? And I always have students go, how do you know you did that one? 55 is bigger than 33, so if I was going to have a different change and not having both legs, that the largest number would be the hypotenuse. So I got 55 squared, and I'm going to subtract 33 squared. And somebody has to actually subtract 33 squared, so we can go back in here and get there and hit a second insert and subtract. And we get that's 1936. And I'm going to take the square root. That's 44. So that was kind of nice. So I'm going to do it this way and find out that after I do this, b squared is equal to 1936. And then b is equal to 44. So did you see how I tried one way, it didn't work? Then I tried the other possibility, and it worked. So that's what we got to do when we do these problems. So b is 44. Here, 42 squared plus 58 squared. That's my first check. So I got 42 squared plus 58 squared. Does this have a nice square root? And remember, second nths. It does not. Does not have a nice square root, so I'm not going to do it that way. I'm going to do it this way. So now b squared is equal to the difference of 58 squared minus 42 squared. And remember, the bigger number goes with the hypotenuse. And keep in mind, this whole time, I am working like this. That's the formula I'm working on the whole time. So now I've got 58 squared minus 42 squared. And that's 1600. Hey, that's totally going to work. So now I got b squared is equal to 1600. So now my b is 40. if I take the square root of both sides. So I've got that done, and I've grouped those together. Okay, my last one, I got 60 and 65. So let's check this out. I've got 60 squared plus 65 squared, and that's 7825. Well, that's going to be a perfect square. That's 9 times 8 maybe? Let's see what it's going. So it's 85, but we'll see. Well, that's 72. So 78 might not be. Let's see what we got. Oh, it's not. Darn. Okay, so we got to do the other way. So now I'm going to go 65 squared, okay, minus 60 squared. Okay, so that's 625, and I take that, and that's 15. So I take that square root, and that's, well, 1525, excuse me. Where was I going with 15? That's 225. All right, so let's talk about what I did. Okay, now I've got 60 squared plus b squared is equal to 65 squared. And that's what I did. B squared equals 65 squared minus 60. Did you notice I've got all my work done and I'm writing it down? And now b squared is equal to 625 and b is equal to 25. Okay, so that's my answer. That I have supportive evidence that I have my work to get that answer. I just didn't guess. And I'm showing the grader how I did it. A town recreation hall needs to build a ramp. Okay, height of the ramp must be 2 feet. Height 2 feet. Okay, the ramp will start 6 feet from the door, 6 feet. To the nearest tenth of a foot, how long will the ramp be? Well, they want C. Well, a squared plus b squared equals c squared. 2 squared plus 6 squared equals c squared. 4 plus 36. Excuse me, 4 plus 36 equals c squared. Okay, now this is 40. It's equal to c if I take the square root. And they want it to the nearest foot, nearest tenth of a foot. So now I got to go second 40 and hit enter and come up with 6.3. So I've got 6.3 is equal to c. So my length of ramp is 6.3 feet. My length of the ramp is 6.3 feet. All right, now find the value of x. Now, did you notice that I've used Pythagorean theorem all the way up to here? I'm now using Pythagorean theorem on special right triangles. Now remember, on a 45-45, these are the same. This is 45-45. This is x, that's a right angle, x is the square root of 2. On a 30-60-90, okay, if this is a 30, well, I'll make that bigger. On a 30-60-90, okay, this is 60, this is 30, 2x, x the square root of 2, excuse me, 3. Let's make that a better 3, the square root of 3. Now, those are the two patterns I'm going to use here, okay? So now, 26, I got to divide by 2, it's 13, put on the square root of 2, okay? Here, in 12, I've got 5 the square root of 2, but this is a leg, and I multiply by the square root of 2, so 5 the square root of 2 times the square root of 2 is equal to 10. So x is 10. Here, the hypotenuse is 12, so half the hypotenuse, because it's a 30-60-90, is 6. And then 6, the square root of 3, is my x value. So that's what equals x. So that's the front page. Let's slide this on. Now, continuing on with my 45-45-90, 30-60-90. Half of 6 is 3, 3 the square root of 2. Okay? So, if I go 3 to the square root, remember this is a 45-45 because it's an isosceles right triangle. This is 60. So, I've got to take my 30, 60, 90, 30, 60, 90, x, 2x, and x to the square root of 3. Well, this is 5 to the square root of 3, and this is 10, according to that. If this is 12, I divide by 3, okay, and slap on the square root of 3. So 12 divided by 3 is 4, right? But then the square root of 3 has got to be put on there. So we got to look at this way. If I look at this, I'm talking about x to the square root of 3 like this here, and I'm dividing by the square root of 3, and people are like, why did you divide by the 3? Because that's what happens when I do that, and then that's for the square root of 3 when I'm done. So there's a bunch of ways you can do it. I do it in my head. 4 times 2 is 8, and so that's 8 to the square root of 3. And I'm just going to group this together so I can use that space for the next problem. Okay. Now in 17, I'm asked to find, using the triangle to the right, the sine of b. I go to b. The sine is opposite hypotenuse. So sine of b is equal to 24 over 26, but it's not reduced. Both of those have 2 in them, so 12/13 is my sine of b. The cosine of b. Cosine of b, still on b. Cosine's adjacent hypotenuse. Okay, so remember, I'm doing so, TOA. Cosine's adjacent over hypotenuse, so my adjacent is 10 over 26. And both of them have a 2, so 5/13. And yes, you must reduce. Okay, the tangent of A. Now, ooh, boy, A, they changed angles on us. The tangent is opposite over hypotenuse. I have no idea why I just wrote that way. TOA. Tangent is opposite over adjacent. Wow. Okay, so I've got tangents opposite over adjacent. So I'm looking at 10 over 24 because this is my opposite to A and this is adjacent to A. And now I can go 5/12 for my tan of A. So find the value of x, round the lengths to the nearest tenth and angle measures to the nearest degree. Well, I know that's 40, so this is 60. This is 50, okay, because it's a right triangle. But they asked me to find x, so I'm really doing opposite adjacent. So I'm doing the tangent of 40, okay, is equal to x over 20. Now this is opposite, this is adjacent, and I'm doing so TOA. Okay, so now I've got to multiply in my calculator 20 tan of 40. Make sure you have your calculator that does sine, cosine, and tangent. Make sure you check the mode. It's in degrees, so I've got it all set. Second, quit. And now I'm going to clear this out, so I got 20. I'm going to do tan of 40. And this is the length, so they're supposed to be to the 10th, so it's 16.8. 16.8 is equal to x. I'm done, and I've shown my work. Now, here, if I got a 13 and a 12, and I'm looking for a degree, and this is, remember, this is adjacent, this is opposite, this is hypotenuse, 2x, I'm standing on x. Now I've got adjacent over a hypotenuse. Adjacent over hypotenuse is cosine, but it's an angle I got to find, so I use the inverse. Inverse helps me find angles. I take my ratio of 12 over 13 and put it in to find my angle value of x. So let's get this over so I can see what I'm doing. I've got the inverse cosine, second inverse cosine, okay, of 12 divided by 13. And that's 22.61, but we're supposed to do to the nearest degree according to our rules. 22.62 is equal to x squared, but they say angle measures to the nearest degree, so it's 23 degrees is x degrees. Now, my next one, let's see if I can keep everything on here. I'm looking for x. I'm standing on 48. X is opposite. 5 is adjacent. So tangent, TOA, tangent of 48. Remember, I'm looking for a side, so I use sine, cosine, or tangent. If I look for an angle, I use the inverses. So now I've got x over 5. opposite over adjacent, so 5 tan of 48 is equal to x. And I'm over here and I check out with my calculator. I got 5 tan of 48. And that's 5.6 rounded to the nearest tenth. 5.6 is equal to x. Okay. Now in 23, I'm standing here on x, and this is opposite, and this is hypotenuse. So this is sine. Sine of, and that's an inverse because I'm looking for an angle value. So it's an inverse of sine. So it's opposite over hypotenuse, 11/23 is equal to x degrees. Second inverse, 11 divided by 23. 28 5/7. But remember, I'm supposed to round to the nearest. So this is 28.57 degrees, but I'm supposed to round the nearest degree, which is 29 degrees. Okay, kind of encroaching on this problem, so we're going to make it a little smaller. Squeak that in there. Now, this next one, I'm supposed to find a side length. See how I'm identifying the side or angle, and I'm flipping back and forth? So I'm supposed to find a side length. I'm standing on 54. This is opposite, this is adjacent, so I'm using tangent of 54 is equal to opposite over adjacent, so 8 tan of 54 is equal to x. So I've got here, second quit, 8 tan of 54. Okay, it's 11.01 or 11.0. 11.0 is equal to x because I'm supposed to round to the nearest tenth. Now, going on to this next one, we've got 8/4 going on for us. And angle 1 is angle of depression. And that's bird to balloon. Angle 2 is angle of elevation. Balloon to bird. Angle 3 is angle of depression. Balloon to hillside. And angle 4 is angle of elevation. Hillside to balloon. Now, keep in mind, depression and elevation. You got a horizontal line. Looking above, elevation. Looking below, depression. Okay, so if you're looking, that's how you know what's going on in 8/4. Okay, moving on. An architect includes a wheelchair ramps in her plans. Okay, for the entrance of a new museum. She wants the angle of the ramp makes with the level ground to be 4 degrees. She wants this to be 4 degrees. Will the dimensions shown in the figure work? If not, what change should she make? Now, she's wondering, is this ramp going to be okay? So I'm going to pretend that we definitely need 8, okay? I'm going to wonder if that 100 is an actual thing that will happen because she doesn't want to find out what the length of the ramp is. She's wondering, will the dimensions shown in the figure work? If not, what change should be made? Should I move the 100 closer? Should it be less than 100, more than 100? That's what we're going to assume. So this is opposite adjacent. So I've got opposite adjacent going on here. And so it's tangent. So tangent of 4 degrees. If she wants it to be 4 degrees, and it is 8 over x. So now, remember, I've got to cross multiply. This is 8 tan x. So this is x tan of 4 degrees is equal to 8. And then I divide. So x is equal to 8 over tan of 4 degrees. So I got 8 divided by tan of 4. Okay, and that's going to be 114. So x is equal to 114 and some change here, 0.4 feet. 0.4 feet. So this will not work. We must make the base 114.4 feet for our ramp. Okay, so I've got my work, and that's what I did, and I'm just checking to make sure what I think I can do will work. Okay, so now a couple is taking a balloon ride. After 25 minutes aloft, they measure the angle of depression from the balloon to its launching place. Okay, 16 degrees. So I'm in a balloon. Okay, we're up here, we're looking down. So angle of depression, my angle of depression is going down, and they said that that's 16 degrees. They are 180 feet above the ground. Find the distance from the balloon to its launching place. Now remember, distance to the launching place. This is our takeoff spot. Okay, I should probably do that in red, right? Takeoff spot. Now, keep in mind, this is also 16 degrees because angle of depression and angle of elevation are the same. So I'm really wondering, how far is this? Okay, now they don't say, they measure the angle of depression from the balloon to its launch place at 16. They are 180 feet above the ground. Find the distance from the balloon to its launching place. Not from the spot below the balloon, or how far down the road is the balloon, or whatnot, or anything like that. So I've read it twice, and I'm pretty sure I want to find h. So I'm going to go opposite hypotenuse. Okay, so opposite hypotenuse, remember SOHCAHTOA, is sine. So sine of 16 is equal to 180 over h. Now, I pop this over, h sine of 16 is equal to 180. And now I've got h is equal to 180 divided by sine of 16. So 180 divided by sine of 16 is 653 feet. So I'm 653 feet away. Okay, so we're 653 feet. 653 feet away from launch place. Now a surveyor is 300 feet from the base of an apartment building. So this is 300 feet from the base of an apartment building, 300 feet. Here's my building. Okay, the angle of elevation to the top of the building is 24 degrees, and her angle measuring device is 5 feet above the ground. So she has a transit. Okay, it's 5 feet above the ground, and from that transit, it is measuring 24 degrees. So this is 5 feet. They want to find the height of the building. Okay, and then we have to include that 5 feet, because that's not truly the height of the building the transit's finding until we find out how far it is from the ground. So first of all, I'm going to find h with 24, and this is opposite over, let's call that x instead of h. Our x is our height of the building, and so it's opposite over adjacent, tangent. So tangent of 24 is going to give me an x opposite over 300. So I have 300. Tangent of 24 is x. So I pop that in my calculator. So I got 300 tan of 24. Okay, and I hit enter. So I got 133.56. So 133.56 is what I'm doing. Now, if they want the angle measure device 5 feet, find the height of the building. Now, they don't tell me anything here, and I'm just going to do the height of the building to the nearest hundredth. So I've got the height so far is 133.57. Now, add in 5 feet. Okay, add in 5 feet because this 5 feet, it's above the ground, so it's 138.57 feet is the height of building. Okay, now, in this next one, we're supposed to write the magnitude and direction of the vector. Okay, now remember, magnitude is this squaring it, so I'm the mag. Okay, the magnitude Now I'm going to use magnitude is equal to pretty much x squared plus y squared. Okay, I'm doing Pythagorean theorem. Okay, and direction. Okay, my direction, first of all, I've got to use the inverse tangent. Inverse tangent. Okay, and remember that's y over x, or opposite over adjacent. Okay, and we'll talk about that looks like real quick. But the first one is negative 3 squared plus 2 squared. Keep in mind, the negative times the negative is positive, so it's 9 plus 4. So my magnitude is square root of 13. Okay, my inverse tangent. Now if I look at this, I go down 1, 2, 3, and up to, I'm here. And I'm up here, so this is 3, 2, okay, when I'm looking at that. So 3, 2, and I know that's negative 3, but we're talking about tangent. I'm talking about this angle. So when I'm looking at this, I go opposite over hypotenuse, or opposite over adjacent, which is tangent. So the inverse tangent for my direction, my inverse tangent is going to give me my direction of 2 over 3. 2 over 3. And I'm just worried about the degrees, so I'm not going to worry about that negative. So I've got the inverse tangent, second inverse tangent, of 2 divided by 3. Okay, so I got 33.7 degrees. Okay, but, and this is 33.7. Okay, I've got to keep in mind that this is north of west. So I am 33.7 degrees north of west. Okay, so those are the things I've got to find here. They go pretty quick. Make sure that we're comfortable with them. Okay, and we'll see what we can do next. We are almost done, so we're going to finish this up as people come in. So this next one, I got my magnitude, which is 4 squared, 16, plus 6 squared, 36. And I add those together, and I got 16 plus 36. Okay, enter, take the square root, and I got 7.2. So that is 7.2. Okay, 1. Because they don't tell me anything for my magnitude, and they don't tell me it's miles or anything. And then again, I'm looking at this, I'm talking about x and y, and my y is over my x when I'm talking about magnitude. Okay, because each time I do this, if I do this, I'm going to go out 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So I'm down here, and I've got 4, 6, and it's opposite over adjacent. Okay, so I'm talking the inverse tangent. And I've got opposite over adjacent. Pop those in my calculator. Inverse tangent. Six divided by 4. And I got 56.3 degrees. So this is 56.3. And again, I got a picture, so I got 56.3 degrees south of east. Okay, it's awfully nice to be able to put a picture in there. I'm just going to get rid of that because it's in my next problem. And my magnitude here is 2 squared plus 4 squared. So this would be 16 plus 4, square root of 20. So I get that, I got 20. I raise that to the 0.5 power, and I get 4.47. That's my magnitude. And then my degree, remember, it's inverse tangent. Excuse me. My inverse tangent of 4 divided by 2. And remember, this is where I'm going. 1, 2, 3, 4, 1, 2. And that's where I'm at. This is 2 high, 4 long. Opposite over adjacent. Excuse me, I flipped those around. My bad. So it's 1, 2. 1, 2, 3, 4. It's up here. So opposite over adjacent, that's where we're at. And I'm going to get that going here. So I got 4 over 2 for my inverse tangent. And I've got 63.4. So 63.4 is my stuff I'm going to be working with. So I'm going to pull that out of there. 63.4. So I got 63.4 degrees, and it is north of east. Now, the last ones we're doing. Oh, resultant. I love the word resultant. I got -9 and 3, which is -6. Okay, and 8 and 2, which is 10. That's all I did. -9 plus 3, -6, 8 plus 2 is 10. That's my resultant. Resultant is just adding? Yep. We got an add in there. You don't even need that if I talk about the resultant. -7 and -9 is -16. And 3 plus 8 is 11. And those are resultant vectors. Now, we haven't done vectors yet. Let's see what we got. And, well, we're going to get those done right now. Okay, so I've got a 28-degree angle. Close the triangle around the 28. Find your x, find your y. So I'm going to find x. X is adjacent, hypotenuse. Oh, I'm supposed to use compass directions there. Oops, sorry. So we got compass directions. Here I've got 28 degrees north of east. Okay, I'm describing the directions. Here, remember I'm closing it in there, so I'm talking about north, 35 degrees west of north. Now, a helicopter lands. Helicopter lands 14 kilometers north. So this is 14 north. This is 55 west. Okay, it followed a straight line. Okay, find the magnitude and direction. Well, we just did magnitude and direction. Magnitude, keep in mind, is the 55 squared plus the 14 squared. My direction, tangent, inverse of my opposite over adjacent. So those are two things we're going to run in our calculator. So we got second squared, 55 squared plus 14 squared. And we're going to hit enter there. And that's 56. So I got 56.73. 5. And then I've got my inverse tangent, second inverse tangent, and I am looking at second quit, clear that, and I got my second inverse tangent of 14 divided by 55 because I want an angle, and I got 14.28. So this is 14.28. We'll say 14.3. So 14.3 degrees north of west. And our last problem, navigation. A ferry shuttles people from one side of the river to the other. The speed of the ferry in still water is 25 miles an hour. So one side to another, ferry is going 25 miles an hour. River flows at 7 miles south. So that's 7, this is 25. Okay, the ferry heads directly west across the river. What are the resulting speed and direction of the boat? So, resulting speed, magnitude, 25 squared plus 7 squared. Okay, direction. Okay, what's the direction? What's my direction? Remember, this is north, south, east, west, so I'm heading west, so I'm going something. So inverse tangent of 7 divided by 25. And I got 25 squared plus 7 squared. And we have an enter, 25.96, and I have the inverse tangent, and 7 divided by 25, and we have 15.64. So we got to remember what those were for. And I've got 25.96, and that's miles per hour, and this is 15.6 degrees. So I am going 15.6 degrees south of west, and I'm traveling at 25.96 miles per hour. Okay, I hope that works out for you all as far as the understanding of what's going on with this review. But if you have any questions, please locate your local geometry teacher. And please keep in mind, as always, I'm Mr. Bloom, and you're not. Have a great day.